Hello everyone, my name is Nikolay Volf. I'm CEO and founder of Gear.exe. And in this company, we basically try to build a perfect application layer, perfect way to develop applications through Web3 space. And obviously, last year we deployed Wire Network, which is kind of our way of how this should be developed. But Wire Network itself is a weighted layer 1 network, so I won't talk about that. What I will be talking is about our new product, which is Gear.exe. And it's basically the same stuff, the same handy way of developing an application, but on top of Ethereum. So, and okay. And when it kind of so basically, application platform is basically a computational platform, and when we try to think out what would be the optimal way of doing computation in Web3 world, and adopting the Web3 values where everything needs to be decentralized, everything needs to be trustless, and obviously everything needs to be censorship resistant, what would be the optimal way of developing an application in this environment. So, for example, we can take Ethereum state at this moment, where thousands of Ethereum nodes doing all the same computations over and over again, and then every you send $1 to your buddy, and then thousands of nodes, despite that this transaction value is very small, it still gets verified by billions of Ethereum stake, for example. It's how the things doing now on Ethereum, where we have both monolithic verification and both monolithic security. And on other side of the spectrum, we can take more optimal solution, maybe for in terms of common sense. You can just put your web server over there and say, okay, guys, I have this web server, just send a request to them, and it will provide a useful work. Obviously, this solution is optimal in terms of useful work it is doing, but it's obviously not a good candidate for a secure and trustless solution. So there might be some kind of trick we can have to make all this stuff optimal in terms of common sense and still provide a value for Web3 auditors, so to speak. And indeed, zero knowledge proofs can be some kind of way to attack this problem. Zero knowledge proofs themselves can be used for many different things, but for one thing they can be used is they basically tell you if I, for example, take this request, put it into this set of instructions, basically program, and then I get this output, and is this correct or not? So basically they can answer this simple question without you needing to do the verification yourself again, or even trusting it's just cryptographic or something. Cryptographic statement that that computations were indeed performed in the way they were previously announced. And if you get back to the website example, then obviously we can just, along with executing user requests, also provide this ZK proof, and everybody can be sure that yeah, did this web server did what it intended to do. Still, there are some problems with obviously censorship in this scheme, but if the zero knowledge proofs are practical in real time, it can be a solution to pretty much any of our problems. That's why guys usually refer to this zero knowledge stuff as ZK. So basically, once they're super practical, super fast, you don't need any much else. And zero knowledge proofs can be also recursive. So, for example, if you have like two web servers, then one web server can rely on the fact that the first web server did the verification right, and also includes the verification of this stuff inside its own proof. So you kind of get two proofs in one, verified at the one time. And so if we kind of think, but zero knowledge self, despite providing this framework for optimal execution, the virtual machine you get from this proof is not really optimal itself. So execution is not optimal. Instead of doing requests that does just one instruction, you get million instructions per every instruction you want to verify, or as you want to make a proof of. Verification is less fast. If you kind of step a little bit back and try to think about the way, maybe there is some kind of way that we take this particular value of zero knowledge proofs and use something instead. This thing called liquid staking indeed can be such a substitution. So liquid staking, what is liquid staking? What is liquid staking, first of all? Liquid staking is a thing, for example, you secure Ethereum network by participating in staking, and then you get, instead of locking your token forever to secure the network, you get a derived token for the fact that you are staking back, and this token is liquid, you can use it anywhere else. And so you can also use it for liquid restaking. And so basically you use the same tokens that you use to secure Ethereum, but do additional job, make it so that it does additional job by securing something else. You can use half of this token, for example, to secure one thing, second thing, whatever. It has this some kind of liquid security where multiple things, but devised by many parts, can be secure many things. And basically, we get the same work done. So all the operators that have this liquid token restaked, they kind of can answer the same questions we would like them to answer, like we answer from zero knowledge proof. So basically, we're asking, is this computation correct? Is this correct? And so on. And we basically get the same value from that. And the good thing also that we don't need actually any new token. So basically, Ethereum token is already there. We just use that, and you don't need to spawn your additional token or whatever. Everything is already here. And there are several solutions to liquid staking. One of the most famous one is EigenLayer. There is also Symbiotic. The guy is doing a great job at kind of commoditizing the service of liquid staking. So let's get back to what actually we are doing. And as I mentioned, we try to provide the best development experience in Web3 space without compromising on anything, like all our stuff running on the typical user hardware, so it can be run on your typical laptop. Applications deployed on our network completely decentralized. They don't need some kind of centralized sequencers or whatever. And the development environment is also super friendly, beginner friendly. You can just write a couple lines of code and the application is just there. You don't need to care about storage, about anything. And considering saying all of I said before, we are doing it in a special way where we basically treat every application deployed in Gear.exe as a small rollup of its own. And all of these rollups, plus everything that happens on Ethereum, they form some kind of rollup swarm, where in this rollup swarm, they are connected by a special networking protocol, and they are aware, first of all, of everything that happens on Ethereum. So you can commission work to any of these applications from Ethereum or from inside this network, and they basically also can communicate with each other. So, for example, one application takes work from Ethereum, and then it can kind of commission additional work to other application, and our networking protocol is kind of routing all these messages to different applications. And then we also have a set of operators. These operators are exactly when we talked about liquidity staking, they're liquidity staking apparatus, and then they have some particular stake on them, so they can coordinate with each other and make sure that this particular application provided this particular results. And they also randomly divided, so they are assigned to different applications. So for example, like 3 operators assigned to this particular application in random, and another group of operators can be assigned to different application at the same time. And they communicate with each other in real time, so that any task that was commissioned to this kind of service can be parallelized not only on hardware level, but also on networking layer. And parallelization is not only about computation, but also about storage access, so it kind of sharded. And good thing about that is also now we're using liquidity staking mechanism, and we can replace it with zero knowledge proofs just very fast, because the verification mechanism is actually very highly customizable and replaceable. And the key things about that is, as with zero knowledge proofs, this system can also generate recursive proofs of its own. And so basically, every operation that starts from somewhere on the Ethereum side, it was the original operation signed by the user, so it's kind of user starts the interaction, and then all the way until it's finished, can have these recursive proofs, so every actor gets some kind of stake at the game. And Gear.exe itself, I mean, I already mentioned our first product, which is Varo Network. And Gear.exe basically a successor to this product, where we take all the good stuff we managed to make as a standalone network and put everything like it is inside the Ethereum itself. So basically, it's programmable with Rust, so it has a WebAssembly virtual machine at the backend. And it's really a very modern way of programming things. You don't need to kind of take design storage or anything. You just write regular program, and our service, our platform, just organizes it so in such way that it just works forever. And obviously, we do it on the regular hardware any typical user has. And we don't need like a supercomputing sequencers and all this stuff, as already mentioned, has high degree of parallelization, and it basically has AI level of performance available from inside Ethereum itself. So you can just send a transaction on Ethereum, and it will spawn all the computational tasks in it and get back the result to the Ethereum. Initially, when we do all of this thing, if you kind of recall what Ethereum is, and I was actually starting my Ethereum, my crypto career by re-implementing Ethereum itself. And if you remember that Ethereum is referred as a world computer, so to speak, I would say that Ethereum is the world CPU, but this thing that we are doing is some kind of GPU for this. And we had this original, we have this name originally as a Ethereum GPU, but kind of we decided to rename it to avoid confusion. But the analogy is still there. So basically, you have this central processor being Ethereum, and Gear.exe is basically a coprocessor that can do massive parallel computation for this computer, for the tasks that this processor is not really designed to do, and has no capabilities to do because it's not powerful enough. And we already have CPU as Ethereum, and now we have Ethereum plus Gear.exe, and this constitutes a full computer. So, and Gear.exe solves many things that Ethereum lacks. First of all, it's obviously limited computation on Ethereum itself, but it solves it not in a way that most rollups do. That basically spawns the separated network where everything happens, and everything needs to be breached in rollup, from rollup, and so on. Rather than that, Gear.exe works in synchrony with Ethereum itself. So it can take work pulls from Ethereum, it can have some work internally as an application platform, and everything, and our platform makes sure that everything of that happens in synchrony, and this basically leads to lack of liquidity fragmentation that we see with most rollups, and also because we are a modern platform, we can use modern techniques, move faster. Modern techniques, for example, we can use pre-confirmation, where user really has very good UX UI stuff, where you can just press the button and gets its transaction just in the second already confirmed by the network, and it's a highly responsive experience. Okay. Thank you for listening to me, who stayed these days. See you all.